to projects. In this video, we are going to explain about the project that is machine learning based missing data imputation in categorical data sets. Before getting into the execution, first let us understand what is the project about. So, when we talk about the data that is being the foundation of any analytical or decision making process, it is crucial to understand that the quality of the data directly impacts the quality of the outcomes. Raw data is rarely perfect and it often comes with lot of problems, things like missing values, errors, or inconsistencies that we call it as dirty data. So now the problem with the dirty data is that it can completely mess up with our analysis. Imagine trying to solve a puzzle where some pieces are missing, some don't fit, and others are duplicates. You can't see the full picture, right? That's exactly what happens when we try to draw insights from incomplete or inaccurate data. Specifically missing data, which is a huge issue because it creates gap that makes it hard to get meaningful results. This isn't just a technical problem. It affects everything from scientific research to business decisions. If the data is unreliable, then any conclusions or predictions we make from that data are also unreliable. And that can lead to wrong decisions or flawed studies, which is something no one wants, especially when lives or critical resources are involved. Moving on, data pre-processing, which involves cleaning, integrating, and transforming data, is crucial for accurate analysis. However, traditional models are often manual, they are slow and prone to errors. These challenges become even more complex when dealing with the inconsistent column names, duplicate records, redundant features, or outliers. Such issues can distort the final analysis and they compromise the reliability of insights. For instance, redundant features can complicate models and outliers can skew the results. Manual processing also increases the chance of human error, which can further underline the quality of the data. So, addressing these problems early ensures that the data is clean and consistent, allowing for more reliable outcomes. Inaccurate or poorly prepared data can lead to decisions based on faulty conclusions. Therefore, solving these issues is essential to achieve highly quality, trustworthy results in the data analysis. Ultimately, proper data preparation lays the foundation for successful, accurate decision making. So, to overcome all these issues, this project aims to make the process of cleaning and fixing missing data in categorical datasets more automated and efficient. Instead of manually handling missing values, the system uses machine learning algorithms to detect where the data is missing and then fills it using appropriate methods like replacing it with the median value. Along with that, Along with addressing missing data, it also cleans the dataset by removing any outliers, which are values that don't fit with the rest of the data, and eliminating redundant features that don't add value to the analysis. Additionally, it converts any non numeric data into numeric format, which is important for machine learning models to understand and process the information correctly. By automating these steps, the system helps to improve the overall quality of the data, making it more reliable for making the predictions and decisions. Essentially, it simplifies what can be tedious and error-prone process, ensuring that the data is in the best shape possible for analysis. And here, the system uses ensemble bagging mix classifier. So this project uses ensemble bagging mix classifier that combines multiple machine learning models that are nothing but support vector machine, KNN, MLP, and working together like a team of experts to improve the data quality. To further enhance data cleaning, it integrates error correction output code, that is ECOC, which helps correct any errors in the data. Once the data is clean, the ensemble model trains on it to make accurate predictions. And the system's performance is evaluated using accuracy, precision, recall, and F1 score. And the approach has been tested on the real world data set, that is hyperthyroid data set. So, which contains missing and incorrect data. Despite these challenges, the system handles the missing data effectively, ensuring that predictions remain reliable. By automating the data cleaning process, the system significantly reduces the manual effort typically required, saving the time and improving the efficiency. It also ensures that the final data is of high quality, leading to more accurate insights and decisions. Overall, the system aims to streamline the data analysis, making it more faster and more accurate. To further improve the performance, this project integrates XGBoost as the extension model. So the extension of the project focuses on improving the system's performance by introducing the more advanced algorithm called XGBoost, which is known for its effectiveness in handling both the classification and also regression problems. XGBoost, it uses a gradient boosting approach, which helps to refine the predictions and boost the overall accuracy. By applying XGBoost to already clean data, the system becomes even more powerful and capable of making precise predictions. On top of that, front-end interface has been built using Flask framework. This interface isn't just a way to interact with the system, it also comes with the user authentication mechanism. So this feature, it will ensure that only authorized users can access it. This means that the system is not only interactive but also safe to use. The front end allows users to test the system, see how it performs and validate the results directly, making it much more accessible and practicable for applications. Moving on to the implementation. To implement the project, we have followed the steps which are mentioned in the flow of work. So first, the required libraries are imported. This step involves importing necessary Python libraries such as pandas, numpy, scikit-learn, and matplotlib, which will be used for data manipulation, model building, and visualization. Then comes data loading part. In this step, the dataset is loaded into the system. Initial exploration is done to understand its structure, features, and potential issues like missing or irrelevant data. And here, hypothyroid dataset has been used. Then comes the handling missing values. So here missing values are identified, they are handled. For categorical features, missing values are imputed using mean and default values. For more complex cases, cross validation with SVM is used to predict and fill the missing values. So we have used SVM to fill the missing values. Moving on, categorical features are transformed into numerical values using label encoding, which is necessary for machine learning models to process them. And then comes the data splitting part. So the data set is divided into features as X and that is the input variables used to make predictions, and the target label as Y, that is the output variable the model will be predicting. That is hypothyroid status. Then comes the visualization part. Data visualization is used to inspect the distribution of classes in the data set and analyze trends such as gender-based differences in the hypothyroid positive or negative rates. Then comes the data splitting part into train and test sets. So the data set is split into two parts, the training set that is used to train the model and the test set which is used to evaluate the model. Then comes building and training the model. Here machine learning models are selected such as classifiers, decision tree, SVM, etc. and trained using the training data set. Then they are evaluated using accuracy, precision, recall and FN score, and they are compared through the graphs of the project. Then coming to the part of front end, a front-end interface is built using Flask, which allows users to input their feature values and get the predictions. The system also integrates user registration and login functionality with the data stored in SQLite database. Then comes feature giving user gives input as features. So the users enter their personal data, I mean features such as age, gender, etc., which are related to thyroid prediction. They give input for the prediction purpose. Then that input is pre-processed at the backend. So the input data is pre-processed to ensure that it is in the correct format for train model to process, which involves handling missing values and encoding categorical data. Train model is used for prediction. The pre-processed input is fed into the train model to generate predictions, helping users to determine if they might have hypothyroidism based on the input features. And that output is displayed to the user through the front end of the application. Moving on to the algorithms used, these are the algorithms which are used in this project, which are existing random forest, proposed SVM bagging mix, and proposed KNN bagging mix. And this is the extension model, XGBoost model. And to implement this project, we need basic requirements, which are hardware and software. So coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And software are application of Python, front-end framework Flask, back-end framework Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let us execute. To execute, we are supposed to open the code folder of the project, which contains source code files. These are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? In the dataset folder, we have the dataset, that is hypothyroid dataset, that is used in the project. So this is the dataset that has been used in the project to train the models to predict the hypothyroid. Let's close this. And in this file, we have the test cases that we will be uploading in the front end to predict the thyroid. Let's get back. And in this model folder, we have the .h5 files, pickle files, numpy files, in which algorithm information is stored. And that will be loaded into the project code during runtime of the application. And in the static folder, this folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. And then we have is the templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the app.py file that we have. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating content, dynamic content to be rendered in HTML templates. And this is the notebook file. This is a Jupyter notebook file which contains the combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is signup.db file. This file is a database file which is used to store the user information. So this is all about the project. This is all about the code folder of the project. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open the command prompt. So here give the command cd, give the space and paste the copied path. Now click on enter. Here if you observe current directory is changed to the code folders path. Now we are supposed to compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port unless configured differently. So this is the localhost and this is the port. So now copy this local link provided by the Flask framework and paste it into any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. This is the web page of the project which is displayed in the browser and this is developed using Flask framework. So here you can see a sign up link, right? We need to click on that for getting signed up. You're supposed to enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on sign in and provide your username and the password. So give username and the password. Now click on sign in. We have signed in successfully and we are redirected to prediction page of the project. Here you can see choose file button, right? We need to click on that for uploading the test case file. Click on choose file. Let us upload this file. Click on open. Before uploading it, let's see what we have in that test data file. Open the dataset folder. Open the test data. So these are the total different features and we have different test cases that we will be uploading in the front end to predict the thyroid. So let's understand few of the parameters. So first we have is the age of the patient and then we have gender of the patient. Then we have is the on thyroxine. It indicates whether the patient is currently taking thyroxine. That's a hormone used to treat the hypothyroidism. And then we have is the query on thyroxine. It's a flag to check if there is a query on uncertainty about whether patient is on thyroxine. Then we have on anxiety on antithyroid medication. That is whether the patient is on medication that blocks the thyroid gland's ability to produce hormones typically used to treat the hypothyroidism. That is hyperthyroidism. Then we have this like it indicates whether the patient is currently ill or suffering from any significant health condition. And then we have the pregnant. It indicates whether the patient is pregnant as pregnancy can impact thyroid hormone levels. And then we have is the thyroid surgery, whether the patient has undergone thyroid surgery, which can affect the thyroid function. And then we have is the I-131 treatment. It indicates if patient has undergone radioactive iodine treatment often used to treat the hyperthyroidism. And then we have query hypothyroid. So it's a flag indicating whether there is a query or uncertainty about the patient's having hypothyroidism. Then we have is the query on hyperthyroid. It's a flag indicating whether there is a query or uncertainty about patient having hyperthyroidism. Then we have lithium. It is whether the patient is taking lithium, that is a medication that can affect thyroid function. And here we have goiter that refers to an enlargement of thyroid gland often associated with the thyroid disorders. Then we have the tumor. It indicates whether there is a tumor related to the thyroid or surrounding areas. Then we have hypopituitary. It is whether the patient has hypopituitarism, a condition where pituitary gland doesn't produce enough hormones that affects the thyroid function. Then we have psych. It indicates if the patient has psychiatric condition which can sometimes be associated with the thyroid dysfunction. Then we have TSH measured. It refers whether the thyroid stimulating hormone TSH levels have been measured in the patient. The next we have is the TSH. It is the actual measured level of thyroid stimulating hormone which helps to diagnose thyroid disorders. Then we have T3 measured. It refers to whether the tridothyroid, that is T3 hormone levels, have been measured in the patient. Then we have is T3, that is the actual measured level of T3 hormone which is involved in regulating the body metabolism. Then we have TT4 measured. This refers to whether the total thyroxine, that is TT4 hormone levels, have been measured in the patient. Then we have is the TT4. It is the actual measured level of the total thyroxine, a hormone produced by thyroid gland. Next we have is the T4U measured. It is a level of T4U which gives an indication of how well thyroid hormones are being taken up by the body. Then we have T4U. It is a level of T4U which gives an indication of how well the thyroid hormone has been taken up by the body. Then we have is the FTI measured. It refers to the whether the free thyroid index has been measured. And next we have FTI. It is actual measured level of free thyroid index that indicates availability of thyroid hormone for the body use. Then we have TBG measured. It refers to whether thyroxine binding globulin, that is TBG levels, have been measured in the patient. Then we have TBG. So this is the actual measured level of thyroxine binding globulin, which carries thyroid hormones to the bloodstream. Then we have referral source. This is the source or reason why the patient was referred for thyroid related testing or treatment. That's a primary care physician, endocrinologist, or self-treated. So this is about the parameters. Now let's upload this file in which all these test cases will be included. Let's get back to the application. Click on upload. So this given input will be pre-processed at the backend and then it will be fed with the trained model. Then we will be getting the prediction. So these are all the values that we have given. So total, these are all the test cases that we have given to the system. And here we got the prediction as positive for the first test case. That means person has the thyroid. And the next one is this test case and it has been predicted as positive. Similarly, for this case, it has been predicted as positive. For this case, it has predicted as negative. Similarly, for all other cases, it has predicted as positive and negative respectively. Now let's check with the graphs. Click on graph. So here, the first graph which we have is the confusion matrix of the extension XGBoost model. So here on x-axis, we have predicted class, on y-axis, we have true class. And this is the accuracy score comparison graph. Here in this graph, on x-axis, we have accuracy score and on y-axis, we have all the algorithms that are trained on the data set to predict the thyroid. And here we have precision score and here we have recall. If you observe among all the models, XGBoost has the highest performance. Now click on sign out. In this way, machine learning models, they successfully impute the missing values and just by giving the input to the application, it will correctly predict the output by addressing those missing values if there are any in that input. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.